This is a quick video over the sodium channel. So what are some of the parts on the sodium channel? Well, let's focus in on the voltage part, the part that reads the voltage. And these are these blue rods, and they're called the voltage sensors. And they can read the voltage across the membrane. These purple guys right here, these are the activation gate. Activation gates. And this little pink guy right here, this is the inactivation gate. So how do all these parts work together to make the sodium channel act as it does? Well, let's erase some of this stuff. And let's say that the cell, which this would be the inside and this would be the outside, we're going to say the cell has a negative 60 millivolts, meaning that it's at rest. So this side's positive and this side is negative. Now these blue rods can climb up and down. Right now, they are the farthest they can be, or they're in the lowest position they can be in. And that's because negative charges are pulling on these positive charges, and positive charges on this side of the cell are pushing on the positive charges inside the blue rods. So what would happen if for some reason, let's just say the voltage across the membrane was maybe 0. So we had 0 millivolts across the membrane. Or let's just say like negative 20 millivolts. So there was still a slight positive. No, let's go with 0. There's just no voltage across the membrane. That would allow these blue rods to begin climbing. So they would go up. And as they went up, the activation gate could open. And as the activation gate opens, sodium ions could begin diffusing through the channel. And as sodium ions diffuse through the channel, this side becomes positive and this side becomes negative. Remember, as a charged particle crosses the membrane, it will change the voltage across the membrane. So over a short period of time, we could actually get the membrane to have 30, not 30 negative millivolts, but 30 millivolts. And that's all due to these potassiums going from a high concentration to a low concentration. So what shuts off this channel? Well, it's actually the inactivation gate. You notice that this gate is tethered, or this ball is tethered to the protein, our channel. And they're actually, when the channel is open in this position, this ball has a high affinity to wanting to be right there. So if it randomly diffused on over, which it would be because it's stuck in this area, it will diffuse on over and it would get stuck here because it has a high affinity to be there. So then the channel would close and we would still have those positively charged, like there'd be positive charges on this side of the membrane and negative charges on this side of the membrane. And we'd still have our ball right here, so no longer could any sodium ions cross the membrane. They couldn't because of the ball. It blocks them. Now at some point, the potassium channels open. And remember, when a potassium channel opens, it allows for the potassium to cross the membrane. And as the potassium crosses the membrane, the voltage across the membrane becomes negative. Remember, it climbs up to a negative 60 millivolts. So now this side of the membrane becomes positive. So this is positive, and this side becomes negative. And when that occurs, the positive charges push on the blue rods, or the voltage sensor rods, downwards. And as the blue rods go down, and remember the negative charges are also pulling on them, as the blue rods go down, the activation gates, which are these purple parts, begin to close. And as they begin to close, this purple little guy, or the inactivation gate, pops out. And we get back to a cell at rest with its sodium channel closed.